Hi folks, I'm going to explain how a rocket is used to send stuff from the Earth to space. I'll start with this demonstration and go all the way to explaining how SpaceX's Falcon 9 rocket manages to send spacecraft to the International Space Station, or even a lander and rover to the moon. A rocket works by throwing stuff out the back, literally. It makes use of Newton's third law. For every action there's an equal and opposite reaction. If the action is to toss something to the left, then the reaction will be that the tosser will be moved to the right. I'll demonstrate using this spring-driven rocket. And this is the spring that's going to be compressed. This chunk of copper is the reaction mass that's going to be thrown away. And this thread right here that goes through the whole thing is what holds it all together. Okay, so let's hang it up as a pendulum and try it out. To cut the thread, I'll burn it. The spring will throw the chunk of copper to the left, while the rocket reacts by flying to the right. In a rocket used for going from the Earth to space, the mass that's thrown out is the byproduct of burning a fuel with an oxidizer, usually liquid oxygen. This oxygen is needed just like it is down here on Earth for keeping a flame lit. Together they're called a propellant, since it's ultimately what propels the rocket forward. In a solid fuel rocket, like the two that were on the space shuttle, the propellant is usually a solid cylinder that gradually burns from the inside out, throwing the burnt results out the back. In a liquid fueled rocket, such as one using kerosene and liquid oxygen, the two liquids are mixed together and then burned. An advantage of this over the solid fuel rocket is that it can be turned on or off as needed. Another type of rocket is a hybrid of the two, where the fuel is a solid cylinder again, but an oxidizer is sprayed through the middle of the cylinder. As long as the spray continues, the rocket keeps firing. When the spray is stopped, the rocket stops firing. But that arrangement alone won't always get you as far as you want to go, for example, to the International Space Station. The problem is that a single rocket like this is too heavy to go all the way, so a solution is to make the rocket lighter as it goes up. It will get lighter as more and more propellant is burnt and thrown out the back, but that's not good enough. So a rocket is broken up into multiple stages, sort of like having multiple rockets stacked on top of each other. SpaceX's Falcon 9, for example, has just two stages. Once the propellant is used up for the first stage, the whole stage is separated and left to fall back to Earth, usually into the ocean. Then the next stage is started up, and when it runs out of propellant, that one too is thrown away. But there's a problem. Once the rocket gets to space and runs out of propellant, if it's not going fast enough, then the Earth's gravity will eventually slow it down until it stops and falls back again. There are two things that fix this problem. The first is that any object set in motion will keep moving unless something else affects that motion. This is Newton's first law, loosely worded. We don't think this way on Earth because there's always something to slow us down. An example is when we throw a ball. The air slows the ball down. But in the space near the Earth, there's very little air, and so once something is set in motion, it'll keep moving for a long time before the few atoms it does run into slow it down enough to require another push. The second thing that's needed to fix the problem is the rocket's speed. We all know what happens when you throw a ball up in the air. The ball falls back down because gravity pulls it back down. But what if you throw it so it goes faster? It'll go further before falling back down. Theoretically, you could even throw it fast enough that by the time it does fall, it'll already be over the horizon. It's even theoretically possible that you could throw it fast enough that it makes a complete circle around the Earth. It would circle around because gravity keeps pulling it toward the Earth. Meanwhile, its forward speed keeps it from being pulled all the way down. When the speed is just right for the amount of gravity that's pulling on it at that height, then it just keeps circling. And remember, an object in motion keeps its motion unless there's something to slow it down. And in the space near Earth, it takes a while before the very thin atmosphere has a big effect. This is called orbiting, and when you've done it, you're said to have reached orbit, or to be in orbit. And that's how a rocket can run out of propellant and yet stay in space near the Earth without falling back down to the Earth. The International Space Station is an example of something that's in orbit right now. It's around 217 miles, or 350 kilometers up, and traveling 17,240 miles per hour, or 27,700 kilometers per hour. And finally, if you want to go from the Earth directly to the Moon, then you'll need to go even faster. The faster initial push is needed in order to get all the way out of the pull of the Earth's gravity before it can slow you to a stop and pull you back. For example, Astrobotic Technology is planning on using a Falcon 9 rocket to send a lander and rover to the Moon sometime in 2015. It'll still use only two stages, but the lander and rover are light enough that that'll be sufficient to do the job. Kind of like the difference between how you can throw a lightweight ball farther than you can throw a heavy one. And that's how a rocket works to send stuff from the surface of the Earth up to space. Well, thanks for watching. Be sure and check out my YouTube channel, Rimstar.org, for more science and tech related videos. You'll find everything from how nuclear fusion works in the sun, to how to do solar cooking using only a car sunshade, to how to make a crystal radio that doesn't need batteries. And don't forget to subscribe if you like these videos, or give a thumbs up, or leave a question or comment below. See you in a bit.